Namaste everyone. In this series of videos, I'll be sharing the experience of researching and developing artificial intelligence for robotics. You will get sneak peek into how I explore and learn things, design and perform the experiments, hunt for potential areas of research, and finally call out the BS. I'll be exploring and experimenting with old and new technologies to see how much have they evolved and are they any better for robotic application. I'll not only ride on the hype and trends of AI, but show if they are of any use at all. This series will show me playing with the robotic arm, exploring various multimodal models, attempt to control the robotic arm using lightweight AI models, and sometimes just being dumb so that I learn and evolve further. In this episode, I will be exploring and testing the Kinova arm. So let's begin. This is the Kinova Gen 3 Lite robotic arm, and it is currently connected via USB to this old shitty computer. And I have set up ROS and RWAYS, which can detect the position, and I'm trying to test some official commands from the documentation given on the Cortex driver API of the Kinova. Now if I just do a small turning command using ROS topics publishing, you can see the arm is moving, and here it shows the real-time feedback, and it will continue until it reaches the limit which is already defined in the driver. And I fucking can't find it. So if I go inside the examples, you can see there's some explanation here, and you will notice that I am the user node here, and this is the Cortex ARM driver node, and which abstracts all these things. It has internal APIs which directly interacts with the ARM. So I am currently this. I'm trying to publish topics or commands like this. I'm identifying the joint identifier 0. I'm giving it a speed which is in radians per second, and the duration is 0, but for some reason it does not seem to work as of now, and it just starts spinning. All right. Catch you once my PubSub is working.
Several days later.
I'm currently trying to figure out how these positions work. So as you can see, this axis remains constant, and the arm is spinning across this thing like there's a sphere, a virtual sphere around it. Let's see what more can we do. This is the robotic gripper that we have. Here is the robotic arm. So it has got a camera attached to it at the front, as you can see. That is Kinova Robotics. And there is the Gen 3 Lite version. So the Gen 3 Lite is a fine 6 DOF. So it has no cameras, just one gripper, can be controlled using Xbox controller. It has just USB ports and all these things, nothing apart from that. It's fine, not bad, but it shivers, not really accurate, and the documentation is pathetic.
3 days later.
Kinova Gen 3 Lite up and running with a robotic gripper and a vision module attached. And this is the 6 DOF model, currently controlled and testing under the web interface, and it works really good. The camera is fine, I'd say. You can read the text, not bad. And was just checking the angular movement under the Cartesian space, and it is really precise. The point stays put. I'll just close the fingers to show you how put it is. See? The point stays just put as it should be. Super nice. And the movements are way smoother as compared to the Gen 3 Lite, which is this one. So it is way better than that. I'm controlling using this virtual joystick, by the way. Nice. I'll continue later with ROS-based control. So now I have some vision data coming in. Here you can see the vision module, and the glowing part is the IR dot projector. And it can see a few things. It can see this elevated platform, this table, and a far away area. So this is how it appears in the screen. This is via ROS, by the way. And as you can see, this is the far side. This is the edge of the table, and this is that foam platform. And if I stand near it, you can see how it looks like. So that is my legs. So the things which are farther appear white, the things which are closer appear darker.
6.5 hours later.
So I've been trying to simulate the robotic arm into Gazebo, and I observed that when values are given beyond its work profile, the robot just crashes. Now I would ideally expect that when a value is given which is beyond the work profile during the inverse or the forward kinematics, it should automatically detect it and stop the command from executing. But in this case, it does not. And this is me trying to figure out the axis and the limits of the robot, which was actually given in the specification, but I did not look at it earlier.
Several days later.
So I have modified the URDF file to add the depth camera and the color camera for simulation purposes, and it is required, as you will see later. Also, I have tried to mimic the behavior from the real camera by adding some Gaussian noise to it, matching the resolution and the FPS and the FOV. Obviously, I have not matched the distortion and the warping of image, but it is fine for now.
The next day.
So now I have created a small server script and a client script to stream the RGB image with the lowest latency possible to the remote computer, which is on the same LAN. And the reason why I'm doing this is because I want to perform the AI inference on other devices which may or may not be running ROS. Thank you, and that's it for this episode.